Mr. Muhammad Abdul Haq. You can prepare this table. Muhammad Abdul Haq. His affiliation is from Tokyo Metropolitan University, Japan. His title is the Heatmap Visualization and Badminton Player Detection using Convolutional Neural Network. So, Mr. Muhammad Abdul Haq, you have 15 minutes to present and then 5 minutes for Q&A. Maybe you may start now.
Okay, thank you everyone. I would like to introduce myself.
Pointer. Oh, okay.
Good morning everyone. I will introduce myself. My name is Muhammad Abdul Haq, and my partner is from NTT, and my professor is from Tokyo Metropolitan University. Thank you for the time. So, my paper in this IES 2022 is Heatmap Visualization and Badminton Player Detection using CNN or Convolutional. So this is the outline of my presentation: the first is introduction, iterative review, method, result, conclusion, and the reference. And so the next is introduction. So in the badminton matches, player positioning is very crucial. The data can be used to evaluate players or improve player performance or increase the sport attractiveness. So CNN or Convolutional Neural Network is used to track a player in a position, so we can get a 2D coordinate using the homography method. And in this paper, we validate our approach using a video from BWF or Badminton World Federation on a channel in the YouTube. So our goals for this research is to build an automated system that can track the position of the player from input from web broadcast video from BWS from YouTube and visualize and then get the output like Heatmap. So there is some limitation in our research. So the data set is from the BWF channel, and the data is used is single match. So we use a single match in women and men single. So we use a YOLO version 3. This is an old method. So this architecture is used to recognize player in this research. You can see in the video that's a YOLO version 3. So the next is multiple object tracking. So this MOT is track multiple moving object, and this is a real-time object detection algorithm that identifies specific object. So in this method, we track position of the player, and we must only track the players only. So I must not detect the judge or the people outside the field. And the next is pattern. So this is what I have done in this paper. So I have done a multiple object tracking. So we can see in these matches, Taisei Ying versus Yamaguchi from Japan. It tracked very well, and the judge didn't track. So the system can only track 2 players in the field. And after the next step is homography. The homography is when the input is broadcast video, and then I stretch using homography from the 4 point of the field, and so the output is lens. And this is the result after detecting the player I can visualize with more interesting way. So it is like a built field in the badminton. So the top is Casey and the bottom is Animal. So this is the final result of our research. So this is the heat map visualization of the player in the field. In this visualization, it is a player numerical versus understand choice. So not only one matches that I process, there are many matches. I remember there is 15 matches that I produced, but I show you in the 3 visualization. The first is this leverage versus transmission game game, and we can see in the blue heat map is always win. I mean, we can see that this is objective result that the player that always point in the center of the field is win. But this is the objective of my see of the result. And we can see the player who always point not in the center. Okay? For like Anders and Thompson, they hit the position in spreading, not in center, and the result is lose. But it's not a must. Then the conclusion is the visualization and the facilitator can help players improve their strategies and the performance. It also identifies hole in their opponent's game. So with the result, the player can see how the players always in the position. So we can see the whole of their opponent's game. And then includes the detailed study, visualization, and explanation of the issues that have been encountered. The majority of current models implementation is automated, allowing them to be completed with higher speed and precision. And this is my reference that I use most, and first is your version 3, and the sum of badminton with computer vision. That's my end of presentation.
Okay. So the next question is the Q&A. Please.
Thank you very much for a very interesting presentation. It makes sense. Can I take a look at the result of your experiment, the blue and the red one? Yeah, it looks blue is more color than the red in comparison. Red, as you said, red is playing front and blue plays a little bit back and far from the net, right? As you said. Is it because of the game or is it because of the angle of the video? You know what I'm saying? Because the time they play is the same, right? Like 10 minutes, 20 minutes, whatever. But the color on the red is much little, I mean, less than blue, I thought. Is it because of the projection environment, or is it because of the angle of video, or is it because of data?
So I get the position in the yellow factor tree. There is a bounding box. So I point in the bottom center. So maybe we can say that's a minimum error. But when I rate some explanation about badminton only, not in the competition, the player who always win is in the center. So I didn't explain about badminton because it's very big thing. So in the badminton there is a base position. Base position is a center, and the center of the badminton field is in here. Yeah, so we can see, and in this third visualization, the Agustus Antonsen is maybe always in the center, and in the game point is near. I mean, they always in the center, and this player is always in the center. But the result is what can you this?
Maybe I mean, like, do you also analyze that the the player who stay in the center is always the good player, or maybe because he can reach more distance, so he can just stay in the center or something like that. Do you have any analysis about that one? Maybe like that.
I cannot say that's a good way to get a win in the matches because I'm not badminton expert, so the answer is for, I mean, only badminton expert can.
Okay.
Yeah, thank you very much.
So very simple question. You are detecting the position of the player, right? So are you detecting the position of the pin also or not yet?
Shuttle.
Pin.
Shuttle.
Girdle.
So in this, I only track the player. But for the shuttlecock detection, I also, in my lab in the university, I also detecting the shuttlecock. But in this paper, I only track the player.
Okay, I see. Maybe tennis also, badminton also, maybe that it's better to combine the
Yes.
player's position and the shuttle position.
That's my research
Calculate
in
the total.
data science.
No. Is there any question here? Maybe the conclusion is this is why the Indonesian badminton player is always lose, because now Japan is always visiting about this one.
It's very small.
Because there are no research about this one in Indonesia.
I see.
Okay, please give applause to the Mr. Mo. Okay, thank you. So we will continue to the class letter from Amani Hamano.